Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at Axonic, Sarah Torrey. In this episode, I spoke with Greg Young about CQRS event sourcing, versioning in event-sourced applications, and his latest endeavor in creating a new programming language. I hope you enjoy this episode, and let's have a listen. Hi, Greg. How are you today?
I'm getting by. Yourself.
Good. Thank you so much for joining me today. We were having a really nice conversation, so I thought I'd press the record button so we can continue. So anyways, can you tell me a little bit about
Sarah's really joking about is that I was laughing that she doesn't have a window.
Window or windows? So Greg, I am so excited to have you today. There's so much I wanted to ask you and talk to you about, but let's start with telling us a little bit about who you are, where you are, background, whatever you'd like to share.
In terms of background, I've been around quite a bit, which I know sounds horrific.
But I sound old now. Do tell.
No, it's even that I went for many years without living anywhere.
Yeah.
I literally just traveled around from place to place, which is kind of fun for perhaps some of the developers out there that are working at doing remote things, especially. There's a new thing that's going on, which is maybe I can work remotely and live in a low-income area and work in a high-income area.
Right.
That's been around for a long time before it started coming out with the new bros doing it.
Yeah. Or with the events of the past couple of years, that's brought on some situations for all of us that we didn't expect. So now you're not traveling as much, though, are you? Or at least for the time being.
Well, traveling has become relatively difficult compared to what it used to be.
Yeah, of course.
I fully expect to go back to 100% travel.
Good. I hope so. I hope we can all go back to that, because I know some of us are getting a little bit restless, which is not good.
Who can imagine? You've
Right,
been locked in a room by yourself for 8 years.
I had a conversation with a friend of mine who is sort of in your situation where she's by herself and working from home and everything, and we were sort of in the reverse situation when we were in a small apartment with 2 kids and a dog, and everything was closed, and so we were all trapped in this one place. And as much as we love each other, we were kind of going nuts a little bit. So and we're like, I don't know which one is better, to have a full house or be alone. I guess they have their own pros and cons, right? But in any case, it's always a con to be stuck in one place. So tell me about your background prior to the pandemic and you not being able to travel. So what did you do before? I'm sure a lot of people already know about you, but how did you get into the computers and went from there?
Okay, so maybe I'm going to go backwards.
Okay.
So I've traveled around for many, many years as a consultant and trainer.
Mm-hmm. And what do you consult and what do you train?
Largely things like CQRS and event sourcing, although consulting, I consult on essentially any project. That's been for at least a decade.
Okay.
Prior to that, I used to work in algorithmic trading systems. Basically, the industry that is the most purely competing industry that you can imagine.
Mm-hmm.
I have a funny story I can kind of give.
Go for it.
So imagine that you are sitting out in Hong Kong, and in this building, which is maybe a 54-story building, there are 4 separate financial companies. All of those financial companies have algorithmic traders inside of them. All of those algorithmic traders all go outside in the evening to go have beers together. So we're in a position where we are directly competing with each other every day, but we are also in a position where we go out and hang out every night.
And have beer together. That's right. Okay.
So it's more like everyone is in this very weird position of I'm trying to get information out of you, you're trying to get information out of me, but we're still friends. And, I might come work for you next week. Does this kind of make sense and how weird it is?
So there's like no competition here, or there's a lot of competition, but you can share.
It's more we all do the same thing, but we compete against each other.
Hmm.
And if I'm good, you want me on your team. And if you're good, I want you on my team. But we're all good together. And
Sure.
you cannot be held back to a team because your career development might be essentially linked to moving to another team. It's probably the most interesting dynamic of employment I've seen anywhere in the world.
Yeah. And then what did you do before that? We were having a conversation prior to me actually hitting the record button.
So prior to doing algorithmic trading, I used to build police systems. Yeah, so I used to build systems for the police.
Hmm.
If you go look at my GitHub photo, which you can probably overlay on top of this, I'm
Right.
actually wearing an NOPD t-shirt.
Oh, that's great.
It's been
So tell
up there that
everybody,
long.
where is NOPD for those of the folks who don't know where that is?
The
New
New Orleans
Orleans?
Police Department.
Yes. Right. The beautiful New Orleans. Yep.
And I was there right up until Katrina.
Yes, unfortunately. And that basically ended your adventures there in the Louisiana area.
But they are
Kind of.
still upcoming. I want to
Oh
move
yeah.
back.
It's a wonderful area and amazing food. I gotta say, amazing food.
Oh dear, oh dear. You need to come up here. I'll make you some red beans and rice. We'll find out what's really going on.
Nice. Sounds like a deal. Sounds like a deal. So before you were in New Orleans, though, um, is that where you worked for NASA, or was that
No, in finance,
a
I was
couple of
actually in
sessions before
Vancouver.
that?
I was in Vancouver mostly.
Oh, that's right. That's right. You did say that. Okay. And what
Um,
did you do there?
Mostly algo trading.
Okay.
Uh, and there's multiple different types of algo trading. What we are working is known as inefficiencies.
Mm-hmm. Which is
So it's basically we found something in the market that we can make money off of. And let me give a kind of canonical example of this. So there's a well-known one, which for people listening, they might not know trading that well and blah 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 blah. But if you have 34 shares of something and you want to sell it, you're obviously not going to get the same price as if you want to sell a board lot, which is 100 shares. There's going to be some premium associated to that because you need to get rid of 34 shares.
yep.
This is what's known as an odd lot.
Mm-hmm.
And traders have been doing this for many, many years. And what
Right.
we're going to do is we're going to build up the odd lots
Mm-hmm.
into board lots and we're going to sell them off as board lots. We make a couple pennies here and there,
Yeah.
but we do it and we make reliable money. Does that kind of make sense?
Yeah.
Now, there's other things that you can do that are similar to this.
Mm-hmm.
Now, when we're talking about odd lots, this might be something that I do 100, 200 times per day.
Mm-hmm.
There are other things that I might be able to do 500 or 1,000 times per day.
Yeah. So adds up.
Instead of making 1 penny per share, I might be able to make 5 pennies per share.
Right.
Next thing you know, you're making a couple hundred grand a year.
Exactly. This kind of, I have to say, this kind of reminds me of the scheme they had. You've seen the movie Office Space, I'm assuming.
Yeah.
It's like, yeah, we just make a couple of pennies here and there, and then he made one error in his code, and then all of a sudden it blew up. Right?
We actually did that.
Oh, my God. So you did Office Space it.
No, we lost an entire month's revenue.
Oh my God, you went the other way. Holy shit.
It was like 2 or 3 bad trades. We lost an entire
Oh
month's
my
revenue.
God. So is that ended your adventures in Vancouver?
No, 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 no. It was just us going, what the hell did we do? How did we end up here?
So I'm hoping you did recover from that.
We were absolutely fine.
That's great. I'm so glad to hear that.
The other problem, which is kind of interesting in trading,
Mm-hmm.
is that you run into issues associated with settlement.
Right.
So I've made a trade with you and you lost money on it, but then you refuse to pay me. There is, in fact, an entire formal process about how to do this. But you now must support that entire formal process as well as your trading
Mm-hmm.
system.
Right. So then, when did you do the NASA adventures? And
That was when I was living in New Orleans.
so you were doing that at the same time that you were designing um, police software.
Yeah, you might need to pull it up, but Stennis Space Center is only about an hour from New Orleans.
Mm-hmm. Yep. So then, when did you decide to go to this field, and how did you get to become familiar with the concepts of DDD, and your interest grew with that, and then you came up with CQRS and followed through with event sourcing and all of that.
So, and I've had this conversation with Eric about DDD.
Yep.
So, what's interesting is that DDD does not start with DDD.
Yep. It's a much older concept that.
If you go back, we can start talking about Alistair Coburn.
Mm-hmm.
We can start talking about hexagonal architecture. We can start
Yep.
talking about. I came up through that.
Mm-hmm.
Although bizarrely, I was not working in Smalltalk at the time, which is highly unusual.
Yeah.
But I got into it by reading all of that.
Mm-hmm.
And dear God, I'm trying to remember how old I was at this point. I was much, much too young that anyone would have cared. Today, I mostly tell people if they really want to go learn all the things associated with DDD and object oriented programming. I know one is more specific there than the other. To actually go back and read all the old stuff.
We actually had a conversation with Rebecca Wirfs-Broggs, who came up with responsibility-driven design, which came prior to domain-driven design. Which a lot of those
Well,
concepts also came from the older patterns and older heuristics and so forth. So we were talking about all these wonderful things that did exist in the past that now we're starting to sort of organize in a different way and appreciate.
I'm just very glad that you don't need to spell her name because everyone should know it.
Yes. Everyone should know
Rebecca has
Rebecca.
done some wonderful work.
Absolutely. And she is an amazing, amazing lady. Such a wonderful person to talk to, and a lot of wisdom and a lot of knowledge, which is amazing. So yeah, we had the same conversation about the old patterns and how these things are not new. They didn't just appear 15 years ago.
Well, the entire concept of a pattern, though, is that they are harvested. It's not that I came up with a new pattern. It's I saw these same things being done in 100 different places and went, this might be useful.
So when you talk about CQRS, and this is the term that you coined, and now it's becoming one of those concepts that more and more people are talking about, and that's how you and I got connected because we were talking about it. So how do you explain the reasoning why you decided to basically separate the commands and queries and the responsibilities, and what was the benefit of that?
So this is actually really, really easy.
Mm-hmm.
So when I go to write data, I want to write data to something similar to a third normal form. But when I want to read data, I want to read data from something similar to a first normal form. Now, the whole point of CQRS is why don't I do both? And we will introduce some period of delay between the two. Like, there's nothing new here. I mean, people have been doing this for decades.
Right.
The the main thing with CQRS is actually that you have event sourcing then behind it. Because with event sourcing, I'm now writing events, which gives me a streaming feed to my read side, as opposed to doing batch updates, as opposed to. And it's not just that I can have my read model, it's now that I can have 4 read models. I can have a key value store. I can have a third model SQL database. I can have a first form model SQL database. And I might have a graph database. And they're all following off and they're all within, let's say, 300 milliseconds of live.
Which makes an enormous amount of possibilities.
The main possibility is that, let's say tomorrow, that you came up with a new format. Okay.
You can
We'll
still
add
use
it in.
it. Yeah.
But the major benefit behind everything is that it's not only can I stick something new in, you can ask me the question of, on January 19th of 2021 at 7:43 and 04 seconds, what would this query have told me?
Right.
If I ran it then.
Mm-hmm.
And here's a precise result to your question.
Exactly.
This is why people tend to come back to the concept of event sourcing. It's more this historical attribution that's capable of. Does that kind of make sense?
Absolutely. Because then you go back and you look at every event that happened at this precise time, and you can actually build your entire, rebuild it if you would. You can just replay all of your events and get every piece of the history you need, basically, which is great.
Well, but the main thing is we can consider our events to be a log.
Right.
And for any query you want to give me, I can only replay that log to a certain point in time.
Yeah.
So all of our queries become temporal. How many items are there in stock? When would you like to know this for? Well, and because everything's written as events as well, there is no information lost.
Absolutely. And I think one of the things that I appreciate about it is that it's in smaller pieces of information, because your events are, being fired and stored in smaller logs, if you would, as opposed to these giant pieces of data tables and so forth, and easier to access, faster, I guess.
You can actually build a fully event source model inside of SQL if you want
Sure,
to.
if you really want to.
It'll just be a bit unusual for your database administrators. So we have a table called transaction. The first column is transaction type. Transaction type tells us which table to join off of.
What could possibly go wrong when you have all these joint tables together?
What could possibly go wrong? But you can do it.
So then this brings me to the next question. You can do it, yes, but would you want to do it?
But what makes me laugh about the entire thing is about how hard it is to do in SQL, but that SQL actually works in the same model underneath.
It's the same way,
If
right?
you actually go and look at how the database stores its data, it works this way. But it's next to impossible to use the database to store the data in the same way that the database uses
To
the data.
decouple them.
But have we reached decoupling or coupling? I mean, if I were to take even a first year student who's been working with SQL databases and I were to ask them what a transaction log is, they would know precisely what I'm talking about. And event sourcing is essentially a transaction log, but then it's completely misunderstood as being this new weird concept that no one has understood before. It's just a transaction log. Well, the main difference is that we have more than 4 verbs in it. Well, and this is one of the major points about event sourcing is that in your typical database, you are going to, in your transaction log, have four verbs. You're going to have create, read, update, and delete. Although reads tend not to end up in your transaction log, although they do if they are transactional. Most reads, they don't end up in the transaction log, but some reads do. Whereas when we talk about event sourcing, we talk about you placed an order, payment was received, order moved to front desk, order picked up by shipping, order shipped, order received. It's the same ideas, they're just in a different way. And these event based systems have been being designed for decades and decades.
At some point, I'm assuming that these patterns stopped being used, and then we kind of went to doing things a bit differently, and now we're back to event sourcing. So, what do you think made it more attractive?
Well, but we're really not back to event sourcing. We're really not back to event sourcing. So what's happened is more that for about 1% of systems,
Mhm.
we refound the value of what we were doing before.
But now we're seeing more
For
and more
99% of
systems.
systems, it's still
Yeah, but see, here's
who
this is
cares for 99.
but here's the interesting thing, because we had this sort of I've had this conversation with um, other friends and colleagues in the past that yes, event sourcing is really beneficial for certain industries and certain things like, I don't know, banking, finances, logging, shipment, and things like that. But now we're seeing them
Well,
in
well, banking and finance are basically
the
intrinsically
same
event
thing, right?
sourcing.
But now we're seeing them happening in other industries as well. Like I had a conversation with Allard Balzer that he was saying that actually the first time he came across someone who was really using event sourcing that wasn't for financial systems or what have you, was for a medical system that were analyzing
Well, but
images.
medical systems have always been event sourced as well.
Hmm.
So I actually have family members who work in the medical industry.
Right.
So when you go to your doctor, you have a medical file, correct? What happens to your medical file? You come in, you are not feeling well today. So you have an appointment with a doctor, the doctor makes some observations of you. He writes them down on a piece of paper and he appends it to your file, correct? He does not take a photo of you and change it out for the photo of you from the last time that you came.
Right. Of course.
Medical is actually a perfect example of an industry that's already event sourced.
But this was in a very specific case, whereas they were analyzing images for, you know, specific things. For instance, analyzing images for a certain disease.
It almost makes complete sense to make it event source. So I get an image, I make a decision. You tell me to make a decision again, I make a decision. I get the image again, you tell me to make a decision. Wouldn't you like to have the history of my decisions upon this?
And isn't it kind of what you were talking about with the project that you were, not to go into details of it, but you were doing with NASA? Because you were looking at a million images
Yes, and
and trying to analyze it. And
it's
yeah.
similar, but what we're looking at here is now more temporal effects. It's not that the image is changing, it's that my perception of the image is changing. And over time, my perception of that image changing is actually important to track. So when I said 90 days ago that there was a cloud here, and today I'm saying there's not a cloud here, this is an important thing for us to be measuring over time. The hilarious thing is, this is also one of the main things associated to Agile. So You can be as agile as you want, but if you cannot show me what happened from the last release to this release, I don't trust you. I'm just crazy. So one of the main things that we do with event sourcing is we will rerun every command the system has ever done. How did it change the event log? So you made your new release. I now look at every diff that comes across my event log. Are these things that I expected or things that I did not expect? And I know this sounds like a relatively trivial task, but when you're receiving millions of transactions per day and you're running across a multi-year data set, this takes a bit of effort. When I have run you across multiple billions of transactions from your history, and now we're going to turn you on tomorrow, I would expect you would be able to work. It would be rather unusual if you could not.
So now you did talk about versioning in event sourcing. Why is that a topic that comes up often?
Because it's the most common thing that people screw up. Um, Let me give a really simple example. So we were talking about vehicles that were coming into a parking lot, and we changed the definition of what a license plate is. Well, prior we said it was a string. Today we say it's a 6-letter character set of alphanumeric characters. So what happens now when you get a license plate with an exclamation point in it? Or what happens now when you get a string with 7 characters in it? But should you stop? Or should you just ignore it and keep going? Suddenly there's a whole bunch of complicated questions here. And we can see this from a very easy perspective of a detective story. So when you have a detective in a detective story, what he might have seen and remembered about a situation might not be the same that he sees and remembers about that situation later. And our problem is that we don't necessarily know what we want to know about today and the future. So if I were going to take an event that we are now on season 3, episode 4 with Greg Young, what other information should I keep about this? I should probably keep the URI. That'd be useful. But maybe I've also decided to keep what do you have on your wall behind you? I might have also decided to keep what were the size of the doors that you had installed? Because maybe you change them every few. But as we go forward in time, the things that I might want to know about what happened today might be different than what I expected today. But we run into a problem backfilling that data because we never had it. Remember that in event sourcing, we come to our current state by replaying our history, even if it's only coming to snapshots. So my interpretation of that history can change over time.
So when it comes to changing these, or rather improving, if you would, these versions, how do you go about it if something is completely screwed up? Is there a way to fix it, or you just kind of move forward?
To be fair, that's a rather long discussion, and I literally have a book I wrote on the subject.
Of course.
The book is actually called Versioning in an Event Source System. And what I say mostly inside of it is that the easiest way to deal with things is on every release you make a new event set, an entire event store. This means I do not have to maintain my entire history. I only have to maintain my current conception of my entire history. So the alternative to this would be that when I go to read events out of my event store that's been existing for 19 years, I would need to upconvert everything to my current understanding of it, which has some benefits because I could have like 20 different understandings of what it currently is. But the upconverting of the entire store makes things a whole lot simpler. And normally we're not doing this like 3 times per week. What we're doing is that we're saying that On April 1st of every year, we upconvert. Or it might be on the 1st of every month, we upconvert. It's basically we're shedding everything that's old. Now we still follow patterns about how to do things, and we automatically convert up. It's just that we're shedding all the old information. The whole idea is that I never replay events from 10 years ago. I only ever replay events from 12 months ago. Because 12 months ago, I replayed the events from 17 years ago. I've brought them forward, and now I have a known level that I need to go back to. Every year that you would have something running adds exponential complexity. So the entire goal is basically to bring forward last year to this year. And this is the same thing that happens in accounting. It's the same thing that happens in a lot of other industries.
So now, Greg, changing gears a little bit. You've been busy in the past, I don't know, a couple of years doing something completely different. Tell me, what have you been up to?
Oh, I've been up to all sorts of fun things.
Well, aside from your virtual talks with me and others and consulting and giving classes and so forth, you've been busy writing a language, correct?
That is correct. I have been
Okay.
writing. I have been writing a programming language, but my
Uh-huh.
programming language is relatively unique.
Okay, tell me more.
The programming language I have been working on is based in design by contract. So the entire goal behind design by contract would be I want to expose as part of a method, not only, let's say, a method name, but also invariants associated with that method or preconditions and postconditions associated with that method. So let me give a really simple example. String.substring. So when you call string.substring, I can tell you that the starting point of the string that you asked me to give you a substring of must be less than the length of that string. And it must be greater than 0 because like asking me for like -5 would just make no sense. Now, for the length that you asked me for the substring, I can tell you that it must be greater than 0. It must be greater than the place you told me, or sorry, it must be less than the place that you told me to start from the place that you told me, or sorry, from the length of the actual string. Now, what if I could formally prove that? But it is that you will get a compile error. So when you actually go to write this code as you're writing it, it will be like, no, 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 no. You have not proven this to be correct. Well, and this is where it starts becoming interesting because most of your unit tests are now they will fail by the compiler. The compiler just tell you, no, that unit test is going to fail. You need to go delete it. You, you said that this string can only be 4 characters. You wrote a unit test that sent me in a 9 character string. Yeah, it's going to fail. And I told you that at compile time. This is a large part of where programming languages have been going. It's towards the theorem proving side. It's quite literally the difference between you demonstrating something to me and me showing mathematically that nothing else could possibly happen. The problem with using these types of languages, which are like strong typing to the ridiculous level, is actually getting in newer developers and getting them to be able to use them. So, what's funny when looking at these types of languages, where I have a form prover, is when you go in and you run them on an existing code base. So when I go to run on an existing code base, one of the things I'm going to find is that it's going to tell me that something like 80 to 90% of my unit tests are going to fail. So I can just go delete all of those unit tests because the compiler already knows. And it also knows about all the unit tests I have not written. It's basically all those failure cases you no longer worry about because you now have a theorem prover. So now I say, when I write down my contract, what the rules of the contract are. And it will ensure that what comes in based on the contract matches what comes out on the contract, which is pretty damn cool. Contracts can also become relatively complex. They, the main difference is, and this is really the thing that's been pushed upon by design by contract people for decades. I can assure you that the compiler approver is not missing anything. And it's covered by 2 unit tests. What you've been seeing as a pattern for all of these types of things is moving towards automation. Because frankly, whether we're talking about moving boxes inside of Amazon or whether we're talking about reviewing code, automation is better than humans. It is measurably better than humans doing it. Not for everything, not for everything. Creativity, they still really suck at. But in terms of, are you following rules? Computers are much, much better at than we are. Theorem proving is really, really awesome. So there are quite a few theorem proof languages still existing today. Um, the varying provers have different levels of maturity. But this is where we're going to be in 20 years. That is one of the sides we're going to be on in 20 years. We're going to be on 2 sides. One of those sides is going to be something like JavaScript. The other side is going to be theorem proofed. The problem with writing theorem proof code is that it takes longer to write because the compiler actually finds any situation that you have not expected. If you have not covered everything that you specified in your contract, you will get a compiler error. It takes a bit more time to get into. But you've written no unit tests. What you still write unit tests, but what you write unit tests for are your happy paths, which is a very, very different way of doing TDD for most people. The only problem that you run into, and this is a really, really big problem, is when you try to take an existing code base and you try compiling it with a compiler like this, you end up getting thousands and thousands of errors. But those are all legitimate places where you currently have bugs. Most of them are silly things that'll probably never happen. Once you start getting into large numbers of bugs that are being reported, often these bugs have relations between them. So it's not that you can go fix like 1 and 1 comes off, or go fix 20 and 20 come off. And you also very often run into that out of my 800,000 bugs, 400,000 of them are caused by 1 line of code. What I've always kind of laughed at is that nobody has done the research that I've seen about how do I take an existing code base and move it to a theorem based system? How do I prioritize my bugs? How do I have yet to see a research paper based upon that. I can come up with many, but I am unsure about their validity.
Sure. Yeah. We talked about um, some of the requirements may change in the future and how to deal with that with versioning and so forth. How can um, how can this type of language that can prove that some things can happen a certain way help for, I don't know, future requirements? Can it at all?
Um, so, at a language level, it cannot because you are only dealing with now. In terms of dealing with things like event storage, you can. Their strategies can be applied. But in terms of the theorem proving at a language level, it only deals with now. It only has the code that it currently
Has to work with, exactly. So in terms of the event store and how it can manage that or deal with that, can you give me an example?
Well, when we deal with events over time, we're going to have versioning strategies over time to convert them into new things or to understand the old things. One of the two. Even when dealing with a theorem prover, because we are materializing these things as types, the theorem prover will still understand the types that we are bringing them to. So, from a theorem proving perspective, everything is still good. Now, the question is, how good are we at materializing this? I am rather certain I could write you a horrific deserializer that completely ignores all the data inside of the thing I was given and produces random data for you instead. Is that correct? But there's no way of me proving that the information that came out of a secondary place is materialized correctly. So that would be the boundary of the area that I can actually theorem prove. And some of the theorem provers, they actually even offer that you can write extensions where I might be able to say, for instance, that I know I'm getting data from that source and I know I'm mapping it to these things, and this is how I map it. So theorem prove that for me as well. Oh, it'll be sometime between the next week and the next 10 years. It's very, very fun stuff when you start getting into it. The main thing that makes it really, really fun stuff, and I hope everyone that is listening really grasps this point, is that it's non-Turing complete. You can prove termination. And this is not for general purpose code. This is for unusual bits of code that happen to be asynchronous. You would normally be writing multiple threads or writing a finite state machine but you can actually prove it.
Really, really interesting. And yeah, this gives me a lot to go and dig out a bit more and learn more about, which is really awesome. So
Next thing you know, Sarah, I'm going to be getting an email from you of, could you recommend a good reference on the pi calculus?
yeah, thanks for sort of opening the doors to this like new possibility realm of possibilities here. I'll be googling for the next 24 hours. So Greg, thank you so much. What is on the agenda for later? Are you traveling again?
Yeah, traveling has been very interesting. It seems like the restrictions are starting to loosen up, but it's more a wait and see type thing right now.
Yeah, yeah, exactly. Right now, you're doing most of your workshops and things online, though, right? You're not doing anything in person.
Correct, but I hope everything is back to in person before the end of the year,
Yeah, I hope so too.
which is not that far off.
No, I mean, we're sort of towards the end of August already. So we only have a few months left. But I really appreciate you being here today. Thank you so much for your time. I know you're busy, busy.
Yeah, no worries.
Thanks. Have a good one.
Great being on with you, and I hope you have a good time.
You too. I hope you enjoyed my talk with Greg. Please join me next time as I discover other interesting topics with wonderful guests. Until then, have a great time and happy coding.